or surface normals are essentially going to be the perpendicular, call it the z-axis, of any surface that you have in three-dimensional space, the origin of which is from the centroid of the geometry. Okay, so remember when we created our grid system the other day, we took, using surface analysis, we took the area node, and then that had a centroid output. Well, we're going to use that centroid output to start mapping in geometry into these cells. But these cells exist in three-dimensional space. So here's kind of the bear that we're going to be battling in just a second. I'll show you what I mean. So let me just turn this one off. Don't want that. So if I take all of these surfaces and I get the centroids of them. So that would be under surface, analysis, and area. And I can plug both of these in. Here's another thing I don't think I explained: additive plugins. So sometimes you'll have a node that will only accept one primary set of data, or one input. And then if you try to pull another one in, much like the Surface 4-point, you can only plug in one, or it gets, if you do it again, it gets overridden with that new connection. I don't know if this one does it. It might. Yeah, it does. So in order to do an additive, you have to hold shift. So if you pull the wire and you hold shift, you notice that the little wire icon, it's got a very, very tiny, almost indiscernible plus sign, and it turns green. That means that it's going to add that wire to an otherwise overriding connection. Okay? So it merges the two data streams into one data output. That's kind of what's happening there. Understand? All right. So moving on from that, once you plug in both of these surfaces into the area, rather than the 84 values that you get, you have double that. So, well, 84. Oh, because it's coming in sets of 2. That's why. That's right. So it's not flattened. So that's why it's reading it as 84, but they're in groups of 2. That's fine for this purpose. So if you recall yesterday, we went through and we grafted a set of spheres onto all of the centroids of our grid. And in two-dimensional space, that was all well and good. It was a three-dimensional form that just was placed wherever they were. And that would even work fine here in 3D because it is a three-dimensional form. But when we're working in 2 dimensions, we have to orient where that two-dimensional plane originates. Okay, so with these centroids, if I just take a curve or a circle, right? It's a simple curve. It's in 2-dimensional space. And I set the base point. Well, let's make it big enough so that we'll see what it's doing. 0 less than 4, I guess. I don't know. We'll figure that out later. So a circle that is 4 feet long. And I want to put it on every single one of these centroids. And I put it there. So I'll make it a little bit bigger so you can really see what's going on. Here in perspective, it kind of looks like from the top, maybe it's kind of working. But then if you get down here in the front view, they're all in the world XY plane. I think you can visually see that. I don't need to explain it anymore. How do we adjust it, right? And so the answer is what I just introduced, surface normals. Okay, so a surface normal is going to read the centroid of any surface, and the origin is going to be perpendicular to that surface's world XY, or not world XY, sorry, that surface's XY. Okay, so when that surface gets created, the centroid is on top of it, and it has its own inherent base. So let's go back a little bit. We still have our centroid here. Let me go back into perspective. Okay, so it's a little bit of a chunk to get to the point where you can map something on. Okay, so there's a few steps we take. We have to, well, obviously first we found the centroid. Then we have to evaluate the surface by finding the surface. Well, is that closest point? So we have to evaluate the surface. Yeah, it is surface closest point. Okay. So, so for surface closest point, we go into surface analysis. And we use this one right here called surface closest point in combination with evaluate surface. Okay, so this is not something that's intuitive. Again, you know, it's not an obvious one. You can't just get in here, drop it in, and start to understand how it works. I'll explain it to you. So, what's that?
Where are those located?
Under surface analysis. So let me make these grouped for you. All right, so we have these two. We have a closest point and we have an evaluate surface. So let's read the descriptions. This one says that it finds the closest point on a surface. And look at the units that it's working in. It's working in U and V, which tells you that it's not going to be isolated to an inherent XY axis. And then here under evaluate surface, it wants a UV point. So UVs have a three-dimensional orientation, right? So when we plug those in, those two are going to speak directly to each other. And then the other thing is it's going to ask for, obviously, the points, and then it's going to ask for the surfaces. And that's a pretty simple connection too. We have the points right here, which are the centroids. We might need to flatten too at some point, but we have the points that are the centroids, and we have the surfaces themselves, which would be these. Oop, I need to add that. Will it work for all of these at once? I'm not sure if it'll work for all of them at once, but we'll see. So then we have our point lists, and they get fed into evaluate. Well, no, the points no. The points don't. The UV does. So the UV gets fed into the evaluate surface, but it also needs the surface connection again. So when I pull that down, I can go back to my surfaces and plug those into, let me zoom in, the S of the evaluate surface, and check out what it's doing. All right? So this is creating an origin. Making sense now how that works? So we've got origin points that are set, and it looks like they're not really on the center. Why not? Do we need to flatten these? Yes, we do. There we go. No, we don't. Why do we want one flattened and the other not? I know, that is hoopla, isn't it? All right, well, for some reason it's giving me the right thing with one flattened and the other one not. I'll play around with that a little bit more, but I don't think in the end this is going to work out, but we'll move on and we'll find out what's wrong with it in a little bit. So now we've got our origin points, and we want to map in a geometry. And so really at this point, this is where we put our circle in, and this is under curve primitive. And that is going to be attached to the point. Okay, the point is going to go into your base. Oops. Or the plane, I should say. And then you establish a radius. So I'll make it 0 less than 5, I guess. I don't know what size we had. It's got to be more, actually. No, that's 0. That's why. Oh, look at that. Oh, I don't have the normal on there. Or do I? Don't have the normal.
How do you make your graph smaller?
Oh, I know what I did. I pulled the wrong circle. Sorry. Oh, the graph?
Yeah, that's annoying.
These little ones here?
Yeah.
So, I actually don't know how you change the size of that or the scale. But you can hide it. So you right click and turn off preview, and then you don't have to see it.
Oh, okay.
Okay, so that's helpful in at the beginning.
Oh, it's just there for purposeful reason?
Yeah, so let me turn that off and get them back on the origin. So what I did wrong is I pulled in the wrong circle. And what you actually need under curve primitive, you need circle CNR. Okay? So what that's telling you is that it's a circle, that's the C value. It has a normal, right? Because we need to speak via normal. And then a radius, circle CNR. So let's get rid of that. We can keep the slider. I'll put that on the radius. And again, the points are going to go into the C, the center, and then the normal is going to get plugged into the normal value. And so here we now have our circles mapped directly to the orientation of each of those planes. Questions? So someday I'll figure out why I only needed to flatten one side of the data string. But for now, we're very lucky that it seems to be working. Right? All right. So we're going to move into a couple of things in a little bit, but I got to stop the video here because that's kind of the complete thought. I had another follow-up thought, but I seem to have forgotten it. But I'll get there eventually.